So the first question is like a blast from the past. Use the Pythagorean theorem to solve, to find the missing side in the triangle below. Who remembers the Pythagorean theorem? Everybody?
A squared plus b squared equals c squared.
Yeah, I hate that way of doing it. I know it works for a lot of people, but I really truly do hate it. And the reason is because one year they did the following diagram. Just up here. Everybody saw the right triangle, and everybody saw the A, the B, and the C, and everybody wrote a squared plus b squared is c squared. And in this diagram, that's not true. When I say a squared plus b squared is c squared, there's an assumption. The assumption is that c is the right angle for the angle and the hypotenuse for the side. And all I have to do to get 90% of you to miss that question is put the c in the wrong place. So it's funny because for the longest time I have not taught this a squared plus b squared equals c squared. I've always taught it leg squared plus leg squared is hypotenuse squared. And when this came out on a state test, and the kids in my class rocked it, they were getting like 90% got it right. And in other teachers' classes, 90% got it wrong. Now, I'm sure there were questions where other teachers' kids did better than my kids, so I'm not trying to say I'm a better teacher. That's not the point. The point is that on this one particular topic, because I took the time to always write leg squared plus leg squared is hypotenuse squared, I could not get tripped up. Now, if you want to continue to do a squared plus b squared is c squared, and you just remember that when you do that, c always has to be the hypotenuse, that's fine. But I prefer to just go without variables and just write on the paper leg squared plus leg squared is hypotenuse squared. Now, the right angle is here. The hypotenuse is always the side across from the right angle. So 6 squared plus 8 squared is x squared. 36 plus 64 is x squared. I add them up, I get 100. Is x squared. I square root both sides. X is 10. Okay? Now, to me, that should be a very simple, very fundamental question coming out of Math 8, which in your case was Math 7 Accelerated. Okay? So hopefully you either remembered that, which is great, but it has been a long summer, and you might have forgotten it. Not a big deal, as long as when I write it up on the board, you're like, oh yeah, I can remember that. Is everybody good?
Yeah.
Okay. So now, let's go on to number 2. And I need to slide this up a little bit in order to get all of number 2 up on the screen. Come on. All right. Let me just make this a little bit wider here. Consider the right triangle below. Jen rides her skateboard from the top to the bottom. Obviously, this is where Jen rides, right, along the ramp. The height of the ramp is 3 feet above the ground, and the length is 15 feet. It takes 3 seconds for Jen to ride from the top to the bottom. So the height is 3 feet, and it says here the length of the ramp is 15. Okay, so what that means is that this, 3, 15, and I'm going to call that x. So do I do 3 squared plus 15 squared equals x squared? Is that what I do? Is that the next step? 3 squared plus 15 squared is x squared? Yes? No? Maybe? Come on, a little bit of a pulse here? No, why not? Right, x is not the hypotenuse, okay? So Phoebe mentioned is she's looking across from the right angle for the hypotenuse, which is good. That's a very good way to word things. It's leg squared. The first leg is 3, so 3 squared, plus the second leg is x squared, has to equal the hypotenuse squared, which is 15. So 9 plus x squared is 15 squared. I should have just write 225. So x squared is, subtracting 9 from both sides, 216. I square root both sides. Does somebody on the calculator tell me what the square root of 216 is rounded to the nearest tenth? Should be in the neighborhood of 14.8, 14.7.
14.7.
14.69, which is 14.7? Okay. So now I'm going to come over to my diagram here, and I'm going to put 14.7. So the first part of doing this is to put it there. Now, this is getting somewhat advanced. God bless. And we're actually beginning to border on the realm of physics. All right? What we're going to ask is this. What is Jen's average speed over the 3 seconds? Now, this is a very, very simple question. Speed is the distance divided by the time, right? For example, when you drive your car, it might say the speed limit is 55 what? Miles per hour. Miles is a distance. Hour is a time. So distance divided by time. It might say 30 miles per hour. Again, distance divided by time. So in this case, if I roll down 15 feet and I do so in 3 seconds, I'm going to do 15 feet in 3 seconds, which is 5 feet per second. Make sense? And we are going to do this type of triangle skateboard question for, I think, 3 days. So you will get very familiar with this over the next couple of days. But now what we're going to do is something very unique and very different. I had the absolute blessing to go to high school, or 5th grade, all of middle school, and all of high school with a true genius. Now, people throw that around like any kid who gets high grades is a genius. No, absolutely not. A genius is unbelievably rare. They're like 1 in 1,000 or 1 in 10,000 for how many people are truly a genius. And this kid truly is a genius. Right now, he's a joint professor at Harvard and MIT. He has written a computer program used in almost every hospital in the world to monitor antimicrobial resistance within the hospital. He is a true super genius. He was an EMT at about 10 years old, 11 years old. And he wrote a book with and for his dad at about 14 years old. And he is one of the most remarkable people I've ever met in my life. I have a very difficult time having a conversation with him. The only 2 things we can talk about are high school and the Monty Python and the Holy Grail. Other than that, I cannot talk to him. And he doesn't even drive because his brain works such a way that he can't drive. Driving is too simple for him. He once said to me that he almost never sleeps. He said that when he gets tired, he looks at the wall and he watches a whole episode of the Brady Bunch from beginning to end. Walls do not show Brady Bunch episodes. He has it memorized. He's a super genius. He truly is. His name is John Stelling, and when he was in kindergarten, he thought he was an idiot because he went up to his teacher, and the teacher said that this motion was a circle. And he said, no, it's not. And she said, yes, it is. And he said, no, it is a composition of a horizontal movement and a vertical movement. And when you put them together, you create a circular movement. And the teacher told him he was stupid, and he was wrong. And he was right, and the teacher was wrong. He is a true super genius. Now, this speed, when you roll 5 feet per second from here, down the ramp, that speed is actually made up of 2 components. Some of it is a speed that goes vertically, and some of it is a horizontal speed. Okay? So, this next question talks about your vertical speed. Yes, you rolled a total of 15 feet, but how much did the height change? How much did the height change, guys? 3 feet. So I'm going to do 3 feet divided by 5 seconds, which is 0.6 feet per second. And that is what we would call the vertical speed. In other words, I'm only going to look at the change in the vertical component of the height. It's changed 3 feet in 5 seconds, so it's 0.6 feet per second. This is the kind of thing John would have instinctively known in kindergarten. And you and I process it in 8th grade. Next, horizontal speed. How do you think I do the horizontal speed? Go ahead. And what is the horizontal length? 14.7, and again, I divide by 5. So 14.7 feet divided by 5 seconds works out to be 4.9, I think. I'm sorry, not 4.9. 2 and 47, 2.94 feet per second. Okay? So we've looked at speed from 3 points of view here. My absolute speed, the speed that you've dealt with your whole life. I went from here to here, it was 15 feet, I divided by 5 seconds. But for the first time, I think, in your life, we broke speed down into its two components. The vertical speed, which is 3 divided by 5, and the horizontal speed, which is 14.7 divided by 5. That's how it works out. Okay? Yes? Oh, because it says up here, oh, I'm sorry, hold it, let me change this back. 3 seconds, I thought it was 5 seconds. So this then changes to 1 foot per second, and this then changes to, and this was 4.9 feet per second. There we go. Okay? Yes?
I just want to know how you found the length. Up there.
The 14.7?
No, in the question. Or it said 15. I just want to know how.
Oh, this, it said it up there. It said that the length of the ramp is 15.
So it's like that.
Bless you. What?
Nothing. I think I get it.
Well, this is what they said. They said that this component was 3 and this was 15.
Well, how do you know if it was that?
Because it said the length of the ramp. And this is the actual ramp. Think about riding a skateboard. Wouldn't that be the ramp of the skateboard? Okay? Yeah, I get hung up on things like that too sometimes. It's like, oh God, that's embarrassing. You know what I mean? Because it's so easy sometimes it's difficult. All right, any other questions? Yes?
Okay, so it's actually really sloppy, sorry, but how did you get the 14.7?
Oh, first time I divided by 5. I should have divided by 3 seconds because it said it takes 3 seconds. So 14.7 was done from the Pythagorean theorem. 3 squared plus x squared is 15 squared. 9, subtract the 9. 225 minus 9 is 216. In other words, I do minus 9, minus 9.
Okay.
All right? Any other questions? Okay, so we've broken everything down. You're going to get to do it just like that tomorrow because I think that's the first time in your life you ever did anything like that. So I don't expect you to get it right. What I do expect you to do is muddy your way through it today, and then tomorrow I'll get going on it. Okay, let's use a graphing calculator. Get your graphing calculators out. Let's teach you how to use your graphing calculator to do a little bit of graphing. Okay, the cool thing is that all you have to know how to do is press buttons. Jaden?
The hard thing is which button.
Well, that's what I'm going to teach you now. I actually have the graphing calculator up on the screen here. See this?
Oh my gosh.
So, life is good. Okay, clear. Now, you know how we've been doing these functions like f of x equals or h of t equals and so on and so forth? That is one way to express a function. Another way to express a function is y equals. So look at this button in the upper left-hand corner here, and it says y equals. Hit that button. If you have anything on your calculator, clear it out. So you just toggle up and down and hit the button clear, and that clears everything out. Okay? Are we good? Right, so everybody should have y equals and then all of these blank areas in y equals.
Oh yeah.
Okay? Are we good?
Yeah.
Excellent. Now, Isabella was absent the other day, so she came to extra help today. And if I remember right, at one particular point you said something like, I don't understand h of t, h of x, all of these other things, what are they? And I said to you, they're all pretty much the same. T is just a specific use of a variable for time. Remember that? Well, look over here. You see this button that says x, t, theta, n? Doesn't it it doesn't really matter if you're doing a word problem and you use n or x, right? Right? So see this button here, x, t, theta, n? You don't know what theta is yet. You haven't gotten there, but x, t for time, n for number. It's all the same thing. So this button is the button we hit whenever we want to input a variable. Okay? So think of this button as the variable button. Hit it. And see how it says x?
Yes.
Okay, so the first graph we want to do on our paper is the graph of y equals x squared plus 2. So now I got to find my squared button, which is over here, and see how it says squared? And then what do you think I hit next? Plus 2. Plus, plus, plus 2. Now, ready? Watch it. I hit graph. Da-da, da-da-da-da, and there's my problem.
Oh, I found.
Okay? Everybody hit graph on your machine, and now you have your calculator did your graph for you. See it?
That's pretty cool.
Okay. Now, it's very important that you learn some terminology here. Let me see this for 1 second. Do I get into this terminology? Hold it, hold it. I want to check how far I go into this. All right, so I don't get too much into labeling things today. Oh, no, I do. Okay, minimum, maximum, zeros, roots. Okay, check it out. Ready? What do you think you call this point down here? A minimum or a maximum? Minimum, because it's the bottom. So that would be the minimum. So if I said to you, write the coordinates of the minimum, let me X this out here. I would say the coordinates are 0, 2. Okay? So you should sketch that on your paper very quickly. Oh, how do you sketch on your paper? Do you remember cartoons when you were a little kid?
Yeah.
And the guy would go like,
No.
oh yeah, like if I wanted to draw, I'd go like,
No. Did not remember that.
and I would draw, and then there the picture would be. Oh, they used to do that in cartoons all the time. You are not allowed to look at the graph on your calculator and go, not a chance. What you're going to do is this. You're going to go to, you see how right above graph it says the word table?
Yeah.
Go to second table.
How do you go back?
Just hit second table.
That was amazing. No. I saw her. She did it.
Okay. Now, if you noticed, here's our graph here. See this? And you see how the graph it goes from like, say, -3 to 3 on the x interval? Hey, you with me here? See how it goes from like -3 to 3? So move up and down your table until you go into the same areas. And because this is a parabola, do you see there's a pattern in the table? Right? So on your paper, you want to plot these points. -311, -26, -13, 0, 2, 1, 3, 2, 6, 3, 11. Go ahead, plot those points very quickly on your graph. Yes?
How do we get to -3? Why do I have to go?
Well, you look at a picture of the parabola here, and you see you could graph any part of the parabola, but this is the only part that has the U, and that's the part we're really interested in. So I look and I go, oh, well, kind of from -3 to 3. I could go from -5 to 5, but then I'd get so big. And if I only did the piece out here, it would actually look like a straight line. It wouldn't look like a parabola.
Oh, okay.
So you look for the part where the U is.
Okay.
And then if you plot those exact points, it's very important you plot those points. Emma, what do you think you do after you plot the points?
Connect the line.
Oh, look at that. There we go. So we play connect the dot, and bingo. There's our parabola, and it's all drawn nicey nice. And we have a beautiful looking parabola, okay? Emma's still working on connecting those dots. All right, so now, once that picture is drawn, let me go back to graph, and let me go back to this. So the point 0, 2 is my minimum, okay? Roots are going to be wherever it crosses the x-axis, and in this case it doesn't cross the x-axis, so it's not there. And what does it say? It says zeros are roots, it says minimum or maximum, and I guess that's about it for now. Okay, now let's go change our function a little bit. Now we're going to graph a second one. Ready? Go to go back to y equals. Clear this out. And what does the next graph say to graph?
Negative x squared plus 4.
Negative x squared plus 4. Okay, put that into your calculator. Go ahead. By the way, guys, there are 2 buttons that look like negative. This is subtract, the one on the bottom is negative. So don't hit the subtract button, okay? Negative x squared plus 4. And then hit graph. All right, so everybody should have that graph. But the problem is people want to sketch it when they see it. What do you have to do to actually graph the graph?
You gotta go to table.
Got to go to table. Go to table, find the U where the numbers repeat themselves, plot the points.
Why didn't it pop up?
Okay, we're going to do another day of this tomorrow, so don't panic. We got a good start on using our calculator. We will continue on.
We need our calculator for homework.
Yes, it's a good thing to use your calculator for homework from now on. How many people do not have a graphing calculator? How many of you have an iPad? Go to the App Store, type in free graphing calculator. Download it onto your thing. Hasta la vista.
It's better than it was. It works.
I know. It's an iPhone.
Here's the deal. It's going to be extremely hard on you if you don't have a calculator and you don't have an iPad and you don't have a phone. On your homework on any given night, probably 80 to 90% of it you will not need your graph for, or your graphing calculator or whatever. But when you hit those questions, I don't care how super smart you are, you're going to need the calculator. Like, you can't do this. This is actually a really easy one that you could do. In time, they're going to get much more complicated. So it's time to like cuddle up to mom and dad and say, Mommy, Daddy. Now start big.
I think it's a night-night.
I have a computer, I have a phone, I have a
If
tablet.
you have a computer, if you go to the App Store on the
Alexis
computer,
Kendra Gomez,
or
Germ
free
205.
graphic
Alexis
calculator,
Kendra Gomez, Germ 205.
you can't get Wi-Fi on your computer.
I don't have Wi-Fi at my house, so I can't download.
But if you can take that computer someplace else
Yeah.
and get the Wi-Fi for 5 minutes and download it, you'll never need the Wi-Fi again.
Anthony Fajardo to the guidance
But you
office,
just gotta
please.
do whatever you gotta do
Anthony
to get it
Fajardo.
one time and get that onto your computer. And the other possibility is if you ask for Wi-Fi, and mom and dad say no, then you ask for a graphic calculator. Or no, then you ask for the iPad. Because the iPad's like, you know, whatever, $400, $500. And then go Kindle. And each time you decrease the cost of the item. And then go, well, if I just get a graphing calculator for $100, then I got it covered. And you will use that calculator until you're senior in high school.
Okay.
All right? So, unfortunately, time has come. Okay? I would give you one of those, but I'm not allowed. All right? You'll always have one in class. And when you get it, leave it home. Don't bring it into school. Because then you could lose it. So tell your parents that you'll buy it, you'll leave it home, and do you have younger brothers and sisters?
I have a younger brother.
So he's going to need it eventually too. What grade's he in?
Fifth.
So by the time you're done, he's ready.
Yeah.
So it's like an 8-year investment. The only problem is they are like $100.
My mom said she could get one from someone she knows, but she
There you
hasn't
go.
get it.
Tell mom it's time. Okay? Tell her we got to get there.